Okay, so this is question 12 of our shadow paper. It says the value v pounds after t years is given by this equation. A and Q are constants. So the idea then is that t and v are going to be the variables that change. It says how many years afterwards, so 2001 would be 1 year after, so 2006 must be 6 years afterwards. So what we're going to do for this first one here is we're going to sub this in. You should check that V isn't in thousands of pounds or tens of thousands of pounds or something. That's very, very common. In this case, it isn't. So we are just going to write 18,000 equals, we don't know what A is and we don't know what Q is, but we do know that this is AQ and then this is a 6. And then if we do the same for the other one, we would get what? We would get 30,000 equals the same A, the same Q, and that will be to the power of 14. So what we want to notice here is that, and in fact you might find this easier to see if you write them the other way up. If we do the bottom equation divided by the top equation, that's going to be quite helpful for us, because what's going to happen is the A's are going to cancel. You're going to be using power rules for Q, and this will just be 30,000 divided by 18,000. So we're going to say that Q to the power of 8 is equal to 30,000 over 18,000. Well, that will actually just be that result there, won't it? We should try and find out now then what Q is. So Q, it says that it's positive, so that's helpful because it's an even power. I need to look at the plus and minus case. Whenever you've got an even power, you need to look out for that. So I'm going to do the positive 8th root of 30 over 18. That's what I would be interested in. And if I do that, I get 1.0. I'm just going to write it to lots of decimal places, okay? And take it from there. So I would get 1.065. That's actually what they wanted. 1.0659. 593. Okay, yeah. So that's fine there. And, well, I've got Q, haven't I? So it sort of seems natural now that I would try and find A. So if I sort of sub into... neither's more convenient than the other, really. So 18,000 equals A, and then this is going to be 1.0659 ... I'd store that in my calculator to the power of 6, and I would say A equals 18,000 divided by that 1.0659 to the power of 6, and I get an answer of 12,271.2. They want to show that it's approximately, so I'll just say that that's approximately 12,300. Okay, so now that we found this, the sort of the classic part now would be, well, if you know these numbers, write them in a model to make it a complete equation and then use it. So where was it? It was up here, wasn't it? So V equals, well, you could do much better than this now. You can actually just say V equals, depending on how the question's going, they say show that. So I feel like they want me to use this number here. So show that it equals 12,300. And what's the next bit? So multiplied by 1.0659 to t. So that would be called a complete equation. Yeah. Interpret the A value. So the question you want to ask yourself is, how do you get A? When is V equal to A? So that's going to be when you make the t equal to 0, because Q to 0 is 1. So that's actually a good word to use here is that's the initial value of what? Of the painting in pounds. Okay, so it's always really, really important to be specific with these interpretations. So the initial value of the painting in pounds. What's Q doing then? So Q is a bit more complicated. So one way that you could kind of do this is you could examine what happens when t is 0, and then you could look at t equal to 1. And what you'll notice is it will increase by 1.0659. So it's actually, what's this doing? It's the sort of the percentage multiplier, yeah? So, or scale factor is another good term. So it's the scale factor for the increase in price per year. That's actually what it's doing. You could talk about multipliers, or you could say the painting goes up by, 6.6% every year. Okay, there's lots of ways you could have written that. And then finally, determine which calendar year the value will first exceed 100. So when would I go over 100 the first time? So if I use my complete model, just in my notes here, because this is a generated question, I'm using that 12,200. So if I said, V equals, again, what was it? It was 12,271 multiplied by 1.0659 to the t. Well, this is a statement, isn't it, about the value. So I would make the value bit 100,000. The inequality, you can do the inequality if you like, but you know that the price is increasing over time. So we could just find the number, and then we could say, it's that year. Okay, so inequalities, you don't always have to necessarily write them. You can just use an equation sign, and you can reason your way through it, I think. Works quite nicely. So the main thing we need to do is we need to recognize that this part needs to be in the denominator, and then we'll need to use some kind of log on handling this part here. Okay, so if I did 100,000 over 12,271, that will equal this number here. Logs, so using log base 1.0659 would be quite an unusual thing to do, and you have to be a little bit careful when you use logs of unusual bases. You can get into situations when they're less than 1 that they have fairly weird results. So what I'm going to suggest that you do here is probably do natural log of 100,000 over 12,271. And then that would equal, if you did a natural log, that enables you to bring t down. So t natural log 1.0659. And then you could just do t being, dividing this bit away. Okay, it's not an exact answer that's required, so there's no need to try and use log rules or anything, exact answers. We don't need to do any of that. Okay, we can just put this in the calculator. So t equals the natural log of 100,000 over 12,271 divided by the natural log of 1.0659. And this will give you 32, so it gives you about 32, so 32.86. So it takes 32 and a bit years for it to go over. The question says during which calendar year. So we are actually interested in the year in that this starts in. So it starts in the 32nd year. So the answer is 2032. So we don't need to round up or anything here. We're just saying what year does this take place in, which is 2032. So there you go, sort of substituting in some unknown, substituting in values to find some unknowns, using that equation, and then trying to do some modelling with it.